Hey, it's Mrs. Cat, and we are here to look at a few more concentration example problems. So we have looked so far at two different ways to make a solution, and one of those is using a solid solute, and the other is with a dilution. So we are going to look at how to make a 800 milliliter solution of 0.5 molar copper 2 sulfate using both of these methods. So over here to the right, this is going to be a solid solute. Down here at the bottom, this is going to be a dilution. Now, regardless of which way we're going to solve to or look at to make this solution, we're going to start our process the same way, which is that we need to know and determine or calculate the number of moles of CuSO4 needed. Now, we're going to do that using this initial information. So we know that volume is going to have to be in liters for molarity, so we can go ahead and just change that by dividing by 1,000. I do want to keep my same number of sig figs, so I'm going to make that 0.8000 liters. And then I also know I want to think about that molarity as being 0.500 moles of CuSO4 for every 1 liter. Okay, that's going to allow us to figure out those number of moles. So I want to know how many moles of CuSO4 are going to be needed to make 800 milliliters or 0.800 liters of solution. I can use that concentration of 0.5000, whoops, one too many zeros, moles of CuSO4 for every 1 liter of solution. Okay, as always, we're going to use proportional reasoning, cross multiply, divide to solve for x. In this case, we're going to multiply 0.8 and 0.5 and get that x equals 0.400 moles of CuSO4. Okay, we're going to use that to find how to make the solution in both methods. Okay, so if we're going to use a solid solute, that means we're going to have to take the mass of that solid on a balance in order to make this solution. So we're going to find mass needed, and then this will be measured on balance eventually. Okay, so in order to do this, we're going to need a molar mass. So I'm going to start there. Molar mass of copper 2 sulfate, we're going to use a periodic table to help us find. So we're going to take all the masses of our individual atoms and add them up. So mass of a copper atom is 63.55 grams. Sulfur, 32.07 grams per mole. And then we've got 4 oxygens at 16.00 grams apiece. Okay, we add all of those up, we're going to get 159.62 grams for every 1 mole. Okay, so that's going to be one side of our proportion. We're looking here for those grams of CuSO4 that we have present in the 0.4 moles that will actually be in the solution. Okay, so we're going to put 0.400 moles. And then we use our molar mass, 159.62 grams CuSO4 for every 1 mole CuSO4. Okay, again, cross multiply, divide. This one turns out to be nice and easy. Here we want to round to the correct number of sig figs, okay, which is going to be the least number that we have in our given measurements. Okay, so if we look over here, we've got 4 sig figs from the 800.0 milliliters. We've got 3 sig figs from the 0.500 molar. That's going to be what we want to round to. Okay, so when we do this, 0.4 times 159.62, we get 63.48 grams, which to 3 sig figs is 63.8 grams CuSO4. Okay, and that would be the mass that we would measure out on a balance. Okay, so if we're going to make this solution, let's go ahead and go down to this next piece underneath here and talk about a procedure for this. Okay, so in order to make this 800 milliliters of 0.5 molar copper 2 sulfate, we're going to have to start by measuring that 63.8 grams of CuSO4 solid using a balance. Okay, once we've mashed that out and put it into a container, we're going to add our solvent. In this case, since it's an aqueous solution, that's going to be water. We want to add enough water to make our 800 milliliters of solution. Now, we don't want to add 800 milliliters. We want to add enough to get to 800 milliliters. Okay, otherwise, we might add too much. Okay, and then once we put those together, we're going to mix it to dissolve. Now, that could be stirring, that could be shaking or agitating in some way, okay, but we do have to make sure that it's mixed so that it can dissolve. Okay, that's using a solid solute. Okay, the other way we could do to make this solution is to use a dilution, okay, where we would use a stock solution. And in this case, our stock solution is a 1.00 molar solution. So here, we want to find the volume of the stock solution needed. To give, in this case, what was it, 0.400 moles of CuSO4. Now, this one's going to be pretty simple and straightforward because we've got a 1 molar solution. So mathematically, it's going to be simple. But if we want to find volume, we want to know how many liters of CuSO4 we need if I need to get 0.400 moles. Now, you all know at this point, I like to put my variable on top. You could certainly leave this as moles over liters, but then that puts the X variable in the denominator. So I know this is going to be a 1 molar solution. So 1 mole CuSO4 for every 1 liter solution. Okay, so cross multiply and solve. Well, it's a 1-to-1 ratio, so it's going to be the same. So this means we're going to have 0.400 liters of 1 molar CuSO4, okay, which is the same as 400 milliliters of 1 molar CuSO4. Okay, it doesn't really matter what you report your final answer in. It makes more sense that we would actually measure it in the lab using milliliters. So now that we know how much we're going to need, we can go over and talk about a procedure for this. Okay, which is going to be pretty straightforward and very similar to what we did. The only difference would be that we are going to measure 400 milliliters of 1 molar CuSO4 stock solution. And I'm going to abbreviate solution, SOLN. Okay. Once we've got that stock solution, then we're going to keep our second and third steps exactly the same. Okay, we're going to add enough water to get 800 milliliters, and then we're going to mix it up to dissolve it. Okay, in this case, that's going to still be stirring, shaking, okay, inverting your container if it has a lid on it, okay, any of those things. Okay, so looking at our different ways that we can make a solution, either using a solid solute and your solvent, okay, or using a stock solution and diluting it with more solvent. Okay, so now we've got a few more practice problems on the back side of this, numbers 1 through 5. It's going to look at some more practice on doing both of these things, right? Using a solid, okay, or determining the number of moles, grams, volume for each of these types of problems. So do these 5. Submit them. If you have questions, please make sure that you reach out. Thanks and good luck.